Okay guys, welcome back to Econ Minds, and let's continue our example related to marginal utilities. And in this example number 9, we are going to find out the marginal utility of a perfect complement utility function. You know that the perfect complement utility function is a mean value function, which is u or utility is equal to the mean of, for example, ax by. And this will change to this format. If the mean is this one, so this will change to ax. If the mean is this one, so it will change to by. So then utility of x, y is equal to ax if a, which is the coefficient of x, is less than b, which is the coefficient of y. And it will be equal to by if a, which is the coefficient of x, is greater than or equal to b, which is the coefficient of y. So now let's find out the marginal utility of x and y in this perfect complement utility function. So we'll have different conditions. First of all, the marginal utility of x, which is equal to the partial derivative of ux y with respect to x, will be equal to, we have two conditions. Think about that. We'll have two conditions. If a is less than b, then the utility function will have this format, ax. Then when we take the derivative of uxy, when uxy is equal to ax, then it will become to a. Then if a is less than b. But the marginal utility of x, if a is greater than or equal to b, then the utility function will change to by. We don't have any x term here, so then it will change to 0. 0. If a is greater than or equal to b. This is the marginal utility of x when the utility function will change to this format. So then, let's find out the marginal utility of y. The marginal utility of y, which is equal to the partial derivative of uxy with respect to y this time, it will change. So also it will have two types, two formats. If the utility function will change to this format, if our a is less than b, so we don't have y terms here. So then if we take the derivative, the partial derivative of this term with respect to y, as we don't have any y here, so it will change to 0. It will change to 0 if a is less than b. But if a is greater than or equal to b, then our utility function will change to this format. Then uxy will become to by. Then if we take the partial derivative of by with respect to y, so we will have the value of b as a marginal utility. It will change, or it will become to b if a is greater than or equal to b. So then we don't have one specific marginal utility for the perfect complement utility function as we had for other types of utility function. For the other types of utility function, we had only one specific marginal utility. For example, for Cobb-Douglas, for CES, for perfect substitute, we only had one format or one type of marginal utility. But in perfect complement, because we have different types of utility function based on which of them will be the mean, so we have two types of marginal utility for each of them. In one type, the marginal utility will be equal to the coefficients. Another type, the marginal utility will become equal to 0. So this is the derivation of marginal utility for a perfect complement utility function. I hope you understand this one, because this is mostly confusing for the student, how they can find out the marginal utility for a perfect complement, or how they can find the marginal substitution, or how they can maximize the utility based on the perfect complement utility function. So if you have any other question, still if it's confusing, you can just write down in the comment. I will try to answer more precisely and clearly in order to understand the concepts of perfect complement or the marginal utility for perfect complement more precisely and comprehensively. Thank you so much again for watching my YouTube channel. I hope you subscribe this YouTube channel if you didn't yet, and share this video with other fellow and colleagues to enjoy together. Thank you so much. See you in the next video. Good luck.